right. Hi, everyone. My name is Priyanshi Singh. I'm going to be talking about MLOps today. This is the last session of the day. I know we have learned a lot in one day, so I promise to keep it simple and easy and concise. All right, so let's get started. We learned about so much of data science, algorithms and like statistical functions we are using, and we learned about algorithms like logistic regression, linear regression. We spent some time on deep learning as well. So when we start learning about data science, of course, these are the building blocks of foundational data science or machine learning projects. And after we have developed a model, which in our case could be deep learning or classical ML model, we want to take it to the next level. And when we talk about taking to the next level, is basically when we are trying to operationalize it. And that's when comes the part of MLOps. It's pretty clear from the name that it's the DevOps for ML. Surprisingly, according to the reports from deeplearning.ai, only 22% of the companies who are using machine learning on their projects have successfully deployed the model. So why, if companies using machine learning and like really building the best model with all the right matrices and all the fancy math applied into it and not taking to the production, why is it so hard? So that's what we will talk about today in this session, and we'll see what are the benefits of using MLOps and how, as a data scientist, as an ML engineer, as a data engineer, we all can work together and have MLOps principles in place. I will give a little brief about DevOps and what MLOps is. DevOps, I think most of the people would know. If not, it refers to bringing together the development, the testing, the operations aspects of software development, following the CI/CD principles to maintain the software development lifecycle. And in MLOps, we try to bring those same CI/CD principles, version principles, software engineering principles, basically, to machine learning projects. There's definitely a difference between MLOps and DevOps, and that's what we will learn about it. So everything is about building a model. Yeah, the goal is when we start approaching a problem with a business understanding, we evaluate like what is a problem, what are we trying to solve today, what model is going to be built if it's a problem like a classification or regression or weight forecasting. So everything starts with like building a model. Like, you know that you're going to build a model for that if it falls in machine learning category. Now, when you think about building a model, there's bunch of steps need to happen before building a model, and there's some steps needs to be taken after you have built a model. So it's not as simple like let's build a model one piece. So I'm sure everybody has seen this process, which will look a lot familiar if you have worked in our data science team or have worked in any like data science school project or any machine learning project either. So everything starts with data ingestion, and I'll slowly move through these boxes. I know we are mostly familiar with these steps taken in the terms of building the model. We definitely start with data ingestion, where we try to find out what are the data sources, what are the multiple data sources, the type of data, and how do I ingest that data to my analysis. Once you have that ingestion piece done, you move on to data analysis and start analyzing your data, where like you do like a lot of like dealing with missing values and build some exploratory analysis over there. And based on that, you move to the next step, which is data transformation. You transform your data with like managing your outliers, or you are trying to hot encode and like deal with categorical values or something like that. Once you have transformed your data, you want to make sure that the data is validated in a way that it supports the machine learning model requirements, and make sure that data is existing in that format, in those like data types and on those features. Then you move on and start splitting your data into training, validation, testing, so that you are ready to go ahead and like take the trainer and start building a model. Once you have built your model, you usually want to validate the model. And once you have validated that model on the validation data, you would do the training at scale with huge amounts of data sets, and want to really scale your training experiment. When you have done the training at scale, everything looks good. The performance is what we were expecting. We have to go ahead the next step and have to roll out the model for production. Once the model is rolled out, we serve it and start monitoring it and like log the performance of it, or any like data drifts or any changes in the whole in the model's performance in the production environment. So when I say DevOps is like a lot of organizations are using machine learning, so why are they not really productionizing it? And the root cause of that is like there's a fundamental difference between ML and like traditional software, which is ML is not just code, it's code and data. So it's a little more additional configuration and effort required to have a machine learning lifecycle in place with MLOps principles. Well, let's go next. Cool. So we'll see about MLOps best practices. These are the best practices. I think being an ML engineer or data scientist, we should be following, because and right, the picture says it all. Like when you start working on the ML infrastructure and you haven't really followed these best practices, it could take a lot of time in just rolling that ML model out of production. So it's a great idea to really have it organized and like have these best practices followed, which basically starts, the first thing first is naming convention. I mean, I think in every programming language, we have naming conventions. In Python, we have like PAPET, a style guide for naming convention. So these are the practices which this naming convention specifically can really help mitigate the challenges of like change anything, change everything type of scenario. So it's basically you just change one thing and like it changes everything if you haven't followed the naming convention easily. And like team members can also get familiar with your project as quickly if you have followed the naming convention, the organization, which they are already familiar with. So it takes really like less amount of time if this principle is in place. Second one is code quality checks. So code quality checks is basically making sure that the functions you have built is doing what it's supposed to do, which is sort of unit testing in a language. You try to write code to check if the code you have written is doing the right job. It's not, it's a crucial thing, because in production environment, it's hard, it can get really hard and like time taking to detect those errors if the unit testing is not in place. Third thing is experiments. Yeah. Experiments, definitely track your experiments. I cannot emphasize the value of tracking your experiments enough, that it is so important whenever you're doing the steps like feature engineering or hyperparameter tuning or model architecture, or a lot of steps you're taking while building the model and like those pre-processing steps. So tracking your experiments can really help you keeping that combination of code, hyperparameters, and pre-processing steps you took, the training data, and like all those combinations tracked in a way that you can always go back and like find out all that metadata about your experiments, about your runs, and it just becomes so easy to really recreate that environment, that experiment for maybe 50% of that experiment you need to use for another scenario. So really, it's so important to track your experiment, because a human cannot really remember the all combinations of ML experiment when you're doing your build, you're developing the model. So fourth thing is like data validation. Definitely data validation is one of the best practices in MLOps environment, where data really, data may create like so many issues in production environment that if you are not validating data, then you're basically have a high risk of running into issues or degrading the model's performance. The statistical properties of data are like different from training data properties, and the data you used to train your model and the data which it's gonna come in the scoring environment is unseen. So there's definitely a block of time should be spent on data validation as part of the machine learning lifecycle. Similarly to data validation, the model validation is equally important to be able to reuse the models in a different and like in a reusable software environment. And to do these type of validations, you need like training pipelines, because models decay over time and they need to be retrained in order to like remain useful. So experiment tracking can help us handle like the versioning and reproducibility of models, but validating models before promoting them to production is crucial, very crucial. And the validation techniques can be used like A/B testing on online validation. If you don't want to do the offline way, it's like the matrices are compared and like then model is validated before rolling out to production. The next is resource utilization. So yes, we all know like these experiments running machine learning tasks, the computes we require are heavy computes because we are often training on a huge amount of data. And the resource utilization is a very important piece to optimize and make it efficient for your organization to keep it not as expensive and be cost efficient over there. And like in the training, I mean, you might need like different type of compute in training environment and inferencing environment, depending on like what you're training using CPUs or GPUs. So understanding really the requirement of your system during the different phases can help your team optimize the cost of your experiment and maximize the company's budget. And there are ways to do this type of resource utilization tests, like profiling tests you can do and provide the data set and the model. The reports really recommend the compute requirements over there. The seventh point is monitor predictive service performance. Definitely, because there are other matrices that determine the performance of a deployed model. Basically, independent of your training data, sometimes you have the latency requirement. Sometimes you have some data feedback loop going on. You have that pipeline want to be in place so that you can monitor that predictive performance and take action if there is anything needs to be changed. Maybe there's some scalability requirement and data just is just increased by 10 times. So you need to scale up with your compute and all the infrastructure you need. So monitoring predictive service performance is also very important. Open communication lines are very important. I think in every notebook, Jupyter, or wherever you write your VS Code, and everywhere the code is written, if the open communication lines are over there, it's very easy for other professionals like team of data engineers or machine learning engineers to get the full understanding and like collaborate as well on the work you have already done. Teams involved in this creation and operation and like monitoring really have this sort of communication. So it's a good practice to have those communication lines in when you're working in a machine learning project. So, all right. So let's see what MLOps, how to bring ML to production, of course, but really like what all goes on when we say MLOps. What does it do? It definitely brings together people, different type of people, different type of job roles. it brings together the developer community or the software engineers, the ML engineers, the data scientists to work together so that the project you're building, the business problem you're trying to solve is maintained in a way where you could reproduce the result, you could reuse it. It is repeatable workflow. And with all that coordination between all these job roles is where it's all major challenge and I would say major benefits are coming from. The process is like continuous integration where you are enabling the individual developers to collaborate more effectively and with each other and blend their work into a code repository. Each time you commit code and it's automatically built and test and like bugs are detected, that's like the principle and the best practices which MLOps offer to make sure that it's a seamless flow of end-to-end and the code commits in your repository. After your continuous integration, the continuous delivery can take the process of build and testing and configuring your deployed model and to build it out in production environment after you would have like checked your code or like changed some other parameters over there. So the key here is basically being the repeatable and consistent process to make sure that it's well understood, it's repeatable by others if you leave the company at some point, and so that people who are left behind can really pick up the work you have done and can really help the process of verifying the correctness and detecting bugs in the process. Okay, yeah, so this is basically how, as a data scientist, I have felt in the past that, but I'm like a data scientist, I don't care about all that, how it scales, how the latency requirements, the whole operationalizing part, like that's not my job. But it's not really true because in a way it is your job. At least I like to think in a way that it is your job to make your work repeatable and reproducible, and it's even easy for you as a person to automate on the work you have already done. So having those set of practices that really combine the machine learning, DevOps, and data engineer, and like really aims to deploy and like maintain those ML systems, it's very important as a data scientist. We all should be doing, and ML engineers and data engineers as well. So let's see, like how we feel about like how is this practice can be in place, and like what are the priorities as a data scientist you think as like as a data scientist we all want to do a quick experimentation, quick iteration of multiple hyperparameter tuning or like multiple experiments of different like bunch of things we experiment with, and we just want to do it quickly so that we don't spend a lot of like time in like scaling and all those things. We really want to start the frameworks we understand, the best of the tools we have worked on, and as a data scientist, you do not want to worry about the management, like governance side, security side, all of that. You do not want to be spend your time. And whereas ML engineers are on the opposite side, where they think of reusability of the tooling and making sure the governance is in place and like it is compliant to the corporate. The latencies required, like latency requirements are met. If it's changed, then what's like the disaster recovery time over there. So basically the idea is to have this friendship built between them so that they can both work in an environment to help organizations succeed and have more machine learning projects in production. So MLOps, for sure, MLOps is ML plus Dev plus Ops, and we'll see like what ML is all about. We can see like it's experimentation, it's data acquisition, it's business understanding, and it's like initial modeling, developing that model, and like basically doing a lot of like data sciencey stuff. But once you have that developed the model, like what more you can do with the DevOps integration in your machine learning machine learning project is basically have a continuous integration of code for whatever changes you are expecting or like in the future may come. You want to have the continuous deployment of your rolled out features over there so that it's fully automated in a way that it's not really manual or you're like broken or siloed in different teams, and a lot of information is missed between coordinating between these different job roles, I would say, to be able to operate on a continuous delivery. So like the users satisfaction is there, the customers or the businesses are they are successful in delivering what they are trying to deliver. There's like full data feedback loop, so that you're taking the feedback from your deployed service and taking it back to the training and really getting back here to the machine learning experimentation, that feedback loop, and getting through that cycle again, so that whatever the feedback was, that the functionalities are changed according to that. This is like the whole idea of how machine learning and DevOps can work together, and it should ideally should be followed as a machine learning best practices to make it really efficient. We'll see some benefits here. It's pretty understandable that MLOps benefits could like automation and like driving the deployments with automation is the goal behind the MLOps, and this is what one of the benefits you're getting out of it. The pipelines make it reproducible, whatever the pre-processing and like tasks you have put together. All artifacts, like your model artifacts, like your environment you used for PyTorch number version or something, or some other like compute infrastructure requirements, all those artifacts can be tagged and like, so that in the future for other experiments, it's easy to like find that metadata with the logging over there. Validation is definitely data validation, as I spoke earlier. Model validation are the software engineering best practices where unit testing and A/B testing is a major part of DevOps process, and that's what we want to have in our machine learning project as well. It's a controlled rollout of capabilities where you are not just done at building the model, and there's like so much more gonna happen after the model is built. The live comparison of the predicted versus expected performance with all that offline versus online validation, and taking that data drift or other sort of changes in the production environment to feed back again. The idea is basically keeping intact to be reproducible, to have this velocity with which these things can flow easily in that cycle, and maintaining the security and company compliance. So there are many jobs and tools involved in production ML, as we just talked about it. Data scientists work in the machine learning environment where they might be using Azure Machine Learning or SageMaker from AWS, or they might be using some other machine learning environments. Like, so mostly data scientists work with like GitHub, their frameworks like TensorFlow, the computes they're gonna use. And so these are the tools which come handy for data scientists. For ML engineers, because they are more focused on the operational side of it, comes on that DevOps, making sure the CI/CD is implemented, GitHub repositories for version controlling and checking of code, committing of code. The Kubernetes service, the deployment of your service, the Azure Monitor to monitor your deployed service. These are some of the tools which ML engineers spend most of the time in their day-to-day life. Whereas like data engineer is more focused on ingestion part of data and making sure that data is available for data scientists to start building on. And tools like Data Lake or Data Factory, SQL databases or Databricks, these are some tools which data engineer work with in their day-to-day job. There are other people like IT to maintain the security. Maybe there's a data analyst in between who is doing a lot of analysis on the collected data before the model is even built. There are business owners, and a lot more job roles are like uh, basically people coming together to have a production ready ML model and roll it out. So it's really like a big it's a like big word of people who are trying to coordinate and really making that coordination easy and smooth, so that everybody's job becomes easier because coordination. um, so let's look at the pipelines. Like, of course, we know there's never a single pipeline to do all those tasks, starting from data ingestion to like monitoring the model in your deployed production environment. So there are multiple pipelines you're going to be using in your end-to-end machine learning lifecycle. You will definitely, data engineer will be working with the preparation of data. So always, like, it always start small as a like a data scientist in a loop where the first conversations are about data availability, and that's where data engineer is trying to collect all the data and prepare it and like catalog the data so that it can move to the next stage, where data scientists can come and start experimentation with the velocity, hopefully, like if the pipelines are in place. Data scientists can come and like train their model and like put like these features, train and evaluate in the pipeline steps, so that it is faster to do a lot of experimentation. Once they have the model which meets business requirement, they go ahead and like serve it in the model registry, and which will keep track of the model versions and like which data set it was trained on, and the other like hyperparameters and all that metadata of the model. Next, when the model is prepared, the ML engineer walks in and like takes it to the release pipeline. This is where the release pipeline goes into and like takes the model into package it, validate it, and like profile it, approve it, and like deploy it as a REST API endpoint, or function environment, or like a Kubernetes environment, so that it can be used in your AI applications. And from here, it's again, the data is collected back and like fed into this data feedback loop is again fed into data lake. And this whole cycle keeps like going on, because it's these people trying, these three roles are trying to have the end-to-end machine learning solution in production. And having these pipelines, these three pipelines, you can break down these pipelines, of course, in more pipelines. But these three on a high level pipelines can help in reproducing what you have built. So let's see. There's a lot of information on the slide. I do not want to go each word here, but wanted to put on the slide deck so you can read it at your house. But I would go in different maturity levels of MLOps, and what does it mean to have like no MLOps or like some MLOps, and like how does a maturity change in your machine learning environment? So basically, level one is no MLOps, where you can think of a scenario where data scientists are siloed and they are not regular communication with larger team. Data engineers are siloed. They are not communicating with data scientists either. The software engineers, they are not, they're also siloed. In their model creation environment, there are like data pipelines, which are gathering data automatically. Maybe the computes may be managed or may not be managed. The experiments may not predictably like tracked, or maybe like if tracked, not like with every pipelines in place. And end result may be a single file, which is manually handed off to software ML engineer, basically, to take it to the production. That's where like we're talking about like there's no MLOps here. And let's see, how do I move from level 1 to level 2? So Level 2, when we start having reproducible model training. So basically, data scientists start working with data engineers. Data engineers start working with the data scientists. There's total communication happening, full coordination. However, software engineers, where the operational people are, they are still siloed and basically receiving the model over the wall and not doesn't have a communication with data engineer scientists. The data pipelines are gathering data automatically. Compute is managed. Your experiment results are tracked. Your training code and resulting models are also version controlled. That's how you have kind of automated your training part with being on level 2 of your MLOps. In terms of release pipeline, you can think in level 2, probably like you have a manual release because there's no MLOps release pipeline in place, and like scoring script is version controlled with test, and release is still managed by software engineering team. Let's move on to the next stage where we are talking about managed model operationalization. In level 3, basically what's happening is like data scientists are working directly with data engineers to convert the experimentation code into repeatable scripts. Data engineers are working with data scientists. Software engineers are also working with data engineers to automate the integration into application code. Along the model creation side, pipelines are gathering data automatically, compute is managed, the results are being tracked, both training code and like resulting models are also version controlled. Release is automatic, coding scripts are version controlled, release is also managed by CI/CD pipeline. This is where you have automated model deployment. However, this is where you see full MLOps implemented in your life cycle, where basically every data scientist working directly with data engineers are working directly with data scientists, and software engineers, these three people working together in a collaborative environment to ship their automated model to the application code. And pipelines gathering data automatically, and like if there's any change in the data, they are detecting that as well. The retraining is triggered automatically when the new data comes in. The PUT is managed, the experiment results are tracked and like version controlled. Both training code and like resulting models are version code as well. Full automatic release of your pipeline for the deployment production environment. Your scoring script is version control and release is managed. So this is where like you can see how there's a full coordination between data scientists and ML engineers and data engineers, and have full MLOps in place so that the whole process is automated with full efficiency of detecting your bugs or any changes effectively. All right, so this slide is to explain a little bit about the workflow, how it works with the data scientist and how they collaborate here. Basically, they start working in code data set environment versioning in a machine learning environment and check the code in the GitHub, where app developers can also collaborate using Azure DevOps to make sure that the code is intact. They take that code to the training of the model. The model is being built in the machine learning pipelines are kicked off. Hyperparameter tuning is happening. So we have our model here. We are validating this model over here in the test app. Again, this is all DevOps pipelines are also going through as machine learning pipelines are also being kicked off. When you have validated the model, you can move to the deployment of the model. And the release app, the release pipeline from Azure DevOps is making sure that whatever the permissions were required for deploying the model in the production environment are taken, any authentications or the security and everything is checked so that it can move to model in the deployment. Then you have the pipelines running for monitoring the model so that you can take the data drift type of things, or any feedback loop which has to happen, go back to the training of model so that you can enhance the model's performance. Or maybe you have new features, or maybe the triggers are different for the model, or hence so on. Lastly, I wanted to show this flow of how the DevOps and machine learning talks to each other. Basically, this is the Azure DevOps build pipeline. When you commit any code changes, this pipeline gets kicked off, which goes and creates the Azure Machine Learning Service workspace and create the compute and publish the pipelines of machine learning, which here kicks into the retraining pipelines, which we have created in our machine learning environment. The pipelines could include training model, evaluation of model, and register model. And after the model is registered, it moves to the AML model management side, where there's a Azure DevOps staging environment, the pipeline, which is making sure the model is packed into a Docker image. It's deployed as a service on Azure container instance in a test environment to test the web service. And this pipeline takes place where the testing is successfully done, then it moves to a manual release gate, or you can have like different triggers to have this release. Then next step in the pipelines can be your deployment to the AKS Kubernetes service, where the model is deployed as a REST API endpoint. The service is tested. It's taking the performance of data back over here in your storage and taking care of like your schedules, your like metrics, or your any data-driven approaches, where you would be able to use and again incorporate in the Azure Machine Learning Pipeline endpoint. So this is a flow of how a machine learning lifecycle, project lifecycle goes in bunch of different small steps, and how and like why it is so important to capture those small steps and follow the principles, best practices of MLOps, so that the whole workflow is repeatable and automated, and really like it becomes easy to detect bugs earlier as well. I'll come to this slide a little later, but I'll go ahead and like share a quick sample of what I have built in my machine learning environment and DevOps environment, so that we can see a little bit MLOps in action. Anyway, yeah. So I'll do one thing. Sorry, bear with me, people. I just have the recording thing up on the screen and I'm not able to move it. So anyway, so here you can see I'm in my Azure DevOps environment, and I have my repository here, which has all sort of like code which has been created by data scientists and provided the different environments and how they have deployed what would be the scoring script would look like, and the scripts to train a model and evaluate a model. So basically, if a team goes in and commit any changes to your repository, I'll show you a small way that I will go and make a commit code change. So in this case, I'm just doing a small code change here, changing the validation sample to like from 5,000 to 7,000, and really just committing this change to my repository. And I go here and commit this change to my repository, which kicks off the pipeline here MLOps Quick Start, which is basically, if I look here, it will do all these bunch of steps, which we will be seeing. This is going to run for some time, so I have already run it, and we can see in previous releases here. For example, like take this release 5. So it kicks off my pipeline here, which is doing basically have multiple steps in a pipeline, that creating a machine learning service workspace and creating compute first, and getting every infrastructure sort of thing set up, and then submitting the training script to it, so that you can see all these steps will be taken. Initialize a job. We can track what's going on once the code change was committed. We can see like how the test deployment was done here. We see here that ACI service creation operation finished, basically in this test deployment stage, it's taking the change and training my model again. And using the training script, train.py, and using evaluate.py to compare the performance of the newly trained model to the previously existing production model, and see if the new trained model is better than what the model we have in production. If that's the case, it will take the latest change and take that model and put that model in production, of course, with some permission and like authentication over there, not just simply go to the production. Right now, the test deployment first checks in the container instance that everything is working perfectly for our deployed model service. So once the testing of deployment finishes, we go back and we would be able to see production deployment and what happens in production deployment as well. Since here I have set up the approval that everything, if looks great in test environment, still ask for the approval from the admin or owners, and go to the agent job. It again kicks off those pipelines, the machine learning pipelines, which have the script as train.py and evaluate and other environment configuration given to it. And we can see here, after the production environment was built, the scoring UI was given here as a REST API endpoint, and we will be able to see the scoring URI here, and it should say somewhere the AKS service connection operation finished. So now that it took that latest change and deployed my model on Kubernetes for the production environment. That's what it's doing in this pipeline, which is right now running. And it will take some time, as you can see, but we can track it here. So it has already tested the deployment. And right now it's in the production step, which it's waiting for the approval. So I can just say approved and go approve it. So, and then it does the production deployment for me. Going back to the machine learning environment where I have my pipelines built and everything, I can see that the endpoint I can see here is like, I have 2 endpoints deployed on 2 different services, container instances, Kubernetes. And as you can see, this test service was updated on 5th June at this time with this, this API call. Basically, it tested with that latest change and updated this REST endpoint on my container instance. And then when I approved it for the deployment in production, it went ahead and it created the on Kubernetes in the production and updated this REST API endpoint based on my code change. So let's go back to the presentation. That was a small piece I want to quickly show on MLOps. I mean, there's a lot of process and a lot of scripts and a code going on behind the scenes to make sure that it's reproducible and like it's linked to each other entity pretty well so that everything works seamlessly. I think these questions I put together to have a high level idea of when you're being interviewed for these roles. And oftentimes these are the MLOps is kind of like overlooked in a way that it's not really talked a lot, because it's like everything is more, I mean, building the model, of course, is the most important. And after the model, how you take that to solve the business problem, basically that's the gap you're bridging, trying to bridge that gap with this. So I think I did cover these questions in my presentation today, and I would love to see that, I mean, after this presentation, if you are able to answer these questions, like what is the difference between MLOps and data science? MLOps is operationalizing your data science projects. Model registry, what does a pipeline look like? Difference between MLOps and DevOps. All these questions you wanna kind of try to work on these questions, basically to do a little preparation for your interviews. I think that can be very helpful. Lastly, I have put some reference links if you want, if you want to build this MLOps cycle, taking that sample data set which I have built in your environment. Please feel free to take these GitHub repositories, and all step-by-step processes there. These are some resources which can help you understand how MLOps is built on different processes, and like how you can build out yourself as well. I do have this book which me and my colleague Julian So wrote on data science solutions on Azure, and the last chapter of this book is all about MLOps as well. So feel free to buy this book and go through it, because this book talks about foundational statistical methods and how would you build those solutions on Azure, starting from statistics, machine learning, pipelines, and ending with MLOps principle in the end. I think this is it. I can take some questions now.
Yeah, thank you so much. This was really helpful. I think it's like critical to make that jump to production. Like, I mean, as you said, right, like there's a gap, and like coming together with all the roles and the right people to work together as a team, I think is something that's really good. There are questions for you in the chat if you want to take a look and answer them. I think we have some time.
Yeah, absolutely. Let me just roll up the first question. Just a second. My is MLOps. How do you handle model decay? PyTorch. Okay. So hold on. I think it's moving so fast for me. So how do you track your experiment? What tools and techniques? I'll answer this question and try to cover others as well. So you can track your experiments using open source packages like MLflow as well. There's Kubeflow community for that. There's newer version of Kubeflow, which is ArgoFlow. You can use those tracking and logging URIs if you want to use open source tools. The MLflow does integrate with Azure Machine Learning as well, and Azure Machine Learning has its own assets which you can leverage as part of tracking your experiments and making sure that your runs are logged with all the information is provided as well. Any tips, hacks? and how to be efficient at tracking MLDL experiments when various hyperparameters might be involved. Yeah, so like I said, whenever we are experimenting with different hyperparameters, definitely have your training script ready, of course, and then when you submit that job, make sure that you are tagging those hyperparameters and logging them. That's the easiest way, and MLflow does a very good job with it. Azure Machine Learning also does a very good job of it. And to be honest, like this is the most important part where I emphasize everyone to log their hyperparameters and the experiment runs. Basically, we wouldn't think that while experimenting, because we are in process of finding the best model and like kind of like waiting to get that model, but making sure that we are following the experiment runs logging, hyperparameters runs logging, it's very important. So make sure that you do it. It makes the job of every like other person very easy. I read Jupyter is where machine models are a good place to start, but not an. I've read about Airflow and worked with it somewhat. Basically, what pipeline tools are good to immerse oneself in? Scales exactly. My hunch is this stuff is only valuable at scale for companies where I work. They have 5,000 crore credit to forecast weather. The problem is large scale for them to even offer me employment. I've been researching various dashboard capabilities. So So Azure pipelines, Azure Machine Learning Pipelines is a great way. You can have a free Azure subscription to start playing with the pipelines over there. There are Azure DevOps pipelines, which does the same thing, but machine learning pipelines are more focused on having the training and test data, like those steps pre-built for you as well. So you don't have to build like with code. A lot of stuff is pre-provided over there so that it helps data scientists and machine learning people to get started as quickly as possible. For your large scale problems, of course, the compute clusters come in handy, where you want to submit a job and spin up the cluster when the job is submitted, so you are not really spending money on the compute all the time. And when your job is done, that large scale, the scaling of load is finished, it will turn down the nodes to 0, and voila, you have your training done on a compute cluster and spent only the money for 10 minutes of use that cluster. So you didn't have to go spend money on buying GPUs or having infrastructure for that. I have researching various dashboard capabilities in Python. You could try to offer an all-one service AI present for other common. I mean, to be honest, like this is dashboarding is basically more about what your organization have it in place. Definitely Tableau, Power BI are great tools to have a lot of functionality supported in dashboarding with the Python support as well, and like machine learning support as well. You can definitely use Plotly for your dashboarding, but there is it's totally like what your organization is preferring, to be honest. Like dashboarding is always um, taking your results to the visualization layer, and basically business users are going to use dashboard, Power BI apps, or like some Plotly dashboards. It's totally up to organizations. Can panelists or attendees recommend a course, ideally project-based, that would work through learning to create MLOps pipelines? Absolutely, and I'll ask other panelists as well. But if you would find in the reference links, I have put some great links to get you started with MLOps pipelines. Any other panelists want to pitch in for any suggestion over there?
I know I'll have to think about that one. So maybe we can compile a list of resources and send them out afterwards.
Sounds good.
Uh,
Um, what is the next question? Oh my God. MLOps is a process that is independent of the technology, right? I can do MLOps in Azure, AWS, or GC, or even in the servers of the company. That's right. You can have MLOps in place in either of those clouds. You basically need like servers for sure, and repositories, the DevOps environment built in for your organization so that you can go ahead and implement MLOps. Between this and methods of machine learning, DevOps methods, and squared engineering. Yeah, I would agree to it because there's a learning curve from being a data scientist and machine learning specialist to incorporate DevOps. But I do think that as a data scientist, we can at least follow the MLOps best practices so that the job of machine learning engineer or the DevOps people is easier and have better coordination and communication so that the machine learning model is actually rolled out to production and it's not just stopped at the stage like, okay, we have the model, now what? Did I miss any question, Micheline? I think I answered most of them. I see comments, so. Is there any question I missed? Somebody wants to raise their hand or something? If I missed your question.
there's one, I think, Varuna just asked.
So do you have any recommendation for managing libraries during experimentation besides managing a requirement.txt, perhaps some services that help creating a virtual with the relevant libraries? This is, to be honest, that's where the environment files, like the when you create those environments and the libraries, the versions you create and want to reuse them. I know to be honest, like, yeah, there are different ways to do it. And managing libraries in a requirement.txt, I have seen people doing that. People have done also like created like multiple various environments, files, so that they could use similar environments on Azure to other machine learning libraries network.
Yeah, I can also add a little bit here. So when it comes to requirements.txt file, in this case, we are tied specifically to Python, right? But there could be also other languages that are used. And if we want to have a little bit more universal vehicle to package environments, we could use Docker, and that's what we prepared for today's um, workshop. We packaged everything in a Docker file, and then you didn't have to install anything except for Docker and running Docker container inside it. I would say Docker is a very universal way to package everything inside, but certainly it's language specific. If you're using, let's say, Node.js, there will be NPM, their own package manager. Python uses pip. So it depends on the language, but if you want to unify everything together, I would certainly go with Docker.
Thanks, George. Yeah, I agree with you. Definitely Docker is the best way to handle your packaging of libraries. Okay. I don't see any more questions, but I'm happy to answer any more questions you have. Please feel free to reach out to me on LinkedIn, and any like information I can help with, I would love to. So Thank you for attending this session today and the workshop.
Wow, thank you so much, Priyanshi. Thank you for taking the time and answering our questions and telling us all about the mysteries of MLOps. I think it's, like I said, it's sort of overlooked sometimes, and it's really excellent to have that insight. So thank you.
For sure.
Yeah, so we have reached the end of our workshop. So I just want to give a big thank you to you all for attending and staying the whole time. Thanks to Carta for hosting us on Zoom. And please look for future talks and workshops by both meetup groups. And then good luck in your data science and ML journey. Yeah, feel free to reach out to us on LinkedIn. Those that use Twitter, platforms like that. And know that we are all rooting for you to get your data science and ML related jobs. Just want to ask, any of the other speakers, if you have any final thoughts or things you wish to say.
I just want to say thanks everyone for attending. I hope you learned something today, and thanks again to the speakers. It's great that everyone was able to give their talk, and we finished early too, a couple of minutes. So great job.
Yeah, thank you everybody for attending, and it's a two-way street. Hopefully everyone learned something new today, including ourselves. So yeah, thank you so much.
Yeah, I want to say thank you everyone for joining today. It was very useful for all of us as well. Great questions, by the way. Yep, it was a great workshop. Thank you.
I'll echo the other organizers' sentiments. Thank you for attending. I hope you enjoyed it and learned a lot, and it was certainly enjoyable to participate.
Awesome. We'll see you all again at a future meetup. So yeah.
Awesome. Bye everyone. Take care.
Bye.
Take care. Bye.